So for this session, we're going to be covering everything to do with vectors that you need to know for GCSE Maths. So we're going to do it in exam question format. It'll start off quite easy and it'll get progressively harder towards the end where we lead on to vector proofs. So let's get started. Just a little bit about vectors. Vectors are displayed in the form just like this as a column vector. Sometimes they're bolded letters as well. So we can't really write bold. So I could say vector A with a line underneath it just to represent that it's a vector, just because we can't write bold. And the column vector, so the top number means it's either going right or left. If it is positive, it's going right. If it's negative, it's going left. And for the bottom, if the number is positive, it's going up. And if it's negative, it's going down. So for example, with vector A, we've got -2 on top, so it means it's going 2 to the left. And on the bottom, we've got 3, so it means it's going 3 up, since it's a positive number. Okay, so let's jump straight into the question. Part AI says do vector A plus vector B. Let's change that to a column vector, since it says write down as a column vector. Vector A is -2, 3. And vector B is 5, -1. And then to add them, we're just adding the top two numbers, and we are adding the bottom numbers as well. So we're doing -2 plus 5 for the top. And we're doing 3 plus -1 on the bottom, and plus -1 gives you -1. So on the top, we've got -2 plus 5, which just gives me 3. And on the bottom, we've got 3 - 1, which is 2. So that's our answer, 3, 2. For the bottom, we've got 2 times A minus B. So 2 times A can be written as so. 2 times vector A, which is -2, 3, minus vector B, which is 5 - 1. Okay, working this out, we've got 2 times -2, which is -4, and 2 times 3, which is 6. So remember, when we're timesing vectors, the 2 times to the bottom and to the top and the bottom. Okay, and we've got -5 - 1. We're minusing this time, so for the top we've got -4 - 5, and on the bottom we've got 6 - -1. For the top we've got -4 - 5, which gives you -9, and we've got 6 - -1, which becomes 6 add 1, which is 7, and that's our answer. -9, 7. Pretty straightforward, a vectors question. Okay, question 2. A is a 0.32 and B is a 0.4 - 1. So they've given us coordinates. Write down as a column vector A to B. So how do we get from A going to B? That's what the arrow means on top. So what you need to do is you need to change the coordinates to column vectors. So since we're going A to B, I'm going to do column vector B minus column vector A. Writing B as a column vector, that's just 4 - 1. We're then minusing A, which as a column vector is 3, 2. For the top, we've got 4 - 3, which just gives me 1. And on the bottom, we've got -1 - 2, which is just -3. So that's our answer. So just to reiterate what we did there, if we're going A to B, we're changing both these to column vectors, and we do the one we're going to minus the one we started from. Okay. Part B, C is the 0.5 - 2 and D is the 0.21. Write down as a column vector C to D. So just like last time, we're going C to D. So what is D as a column vector? Change the coordinate to a column vector, so it's just 2, 1. And we're minusing our starting point, which is C. Writing that as a column vector is 5 - 2. For the top, we've got 2 - 5 - 3. And we've got on the bottom 1 - -2. The minus becomes positive. So 1 plus 2 is just 3. And that's our answer. Okay. Moving on. A, B, C, D, E, F is a regular hexagon with center O. So the reason why they've told us it's a regular hexagon is we know that this here is A. So therefore, this here would also be A. E to F would be vector A, and CB would be vector A as well. So we could say all these are also vector A. And likewise with the other parallel lines, so I'll just use a different color. OB, FA, and DC, they would all be vector B. It's probably worth putting arrows on as well, just to be very explicit which way it's going. So they're parallel to OB, so therefore these would also be B as well. So yeah, that's the significance of saying it's a regular hexagon. So we're taking into account parallel lines. I'm just going to rub that out for now, but just keep that in mind, which is why they've told us regular hexagon. And they've said center O. So O is exactly in the middle of the hexagon. So we could potentially make lines here, is what it's saying, which would be the same as these vectors here. So that's the reason why they've told us center O. So there's always a reason to tell you something in the question, I guess is the point we're trying to make here. They've given us two vectors, OA is A and OB is B, which we can see on the diagram. Find in terms of A, vector AD. So we want to start from A and get to D. So just like we said before, we could potentially draw a line down here, since O is the center. If vector A to O is A, then D to O is also A as well. So I'll just put that here. D to O is also A. And to get from A to D, so I can put it here, to get from A to D, I'm going to go AO first. Let's put that down. I'm going to go to A to O first, and then I'm going to go O to D. It doesn't matter which path you take, by the way. So say, for example, if I took this path to get there as well, I would still get the same answer. Okay, so what is A to O? Well, O to A is positive A, so the opposite direction, that would be minus A. And same for OD. We know DO is A, and we're going the opposite direction, so it's minus A. And minus A is minus 2A. So vector AD in terms of A is minus 2A. Moving on, find in terms of A and B the vector AB. So where is AB? AB is this part here, which we don't know that vector, so we need to find another path to go from A to B. So we could say A to B is, we can go A to O, and then we can go O to B. It's worth writing this down to the examiner so you can show that understanding. So we're going A to O, and then we're going O to B. And A to O, we know that's minus A, since we're going against that direction. And then O to B is just B, so plus B. And that's our answer for that one, minus A plus B. Let's bring this down. So final answer is minus A plus B. And then for part C, it says find in terms of B vector AF. So AF, how can we get to AF? So A to F is just here, and we've already said that it's parallel to BO. So if B to O is minus B, because we're going in the opposite direction, if that's minus B, then therefore A to F would also be minus B as well. So minus B. I think where a lot of people get confused with vectors is they say, how do I know which path to take? Because there's many paths. It doesn't matter which path you take, as long as you start at the starting and you end at the ending. So for example, here we start at A, so we've got A here, and we've ended at D, and you can see we've ended at D here. For this one, we started at A, which we can see here, and then we've ended at B, which we can also see here as well. Okay, moving on to question 4. We've got a triangle here. It's told us vector OA is 5A, which we can see here. It's told us OB is 3B. M is the midpoint of AB. So it says here M is the midpoint of AB. So what's the relevance of that? Well, if I find the vector AB, so say all of this vector here, then AM, so this here, AM would be half of all of AB. Likewise with MB, that would also be half of all of AB. So that's the relevance of telling us that M is the midpoint of AB. It's always worth breaking down these questions as you're reading them. Don't read all of it and then try to answer the question so you understand what's going on. So M is the middle. Find in terms of AB, vectors AB. So how do I get from A to B? Well, I could go down this path. I could go AO and then I could go OB. So let's go down that path. So I could go for AB. I'm going to go AO and then I'm going to go OB. AO is going against the 5A, so it's going to be minus 5A. And then OB, we're going in the direction of 3B. So our answer is just minus 5A plus 3B. Awesome. Moving on. Find in terms of A and B the vector AM. So AM, so this one here, AM is half of AB, as we've just said. Yeah, so AM is half of AB. So if we found out what is AB, then we can work out what AM is. So let's work out what AB is. AB, we've already worked out in the last question, that's minus 5A plus 3B. So to work out AM, we know that's half of AB. So we're just doing a half times AB, which is minus 5A plus 3B. So therefore, that gives us minus 5 over 2A plus 3 over 2B. And that's our answer. We'll bring this down to here, where this is our answer. Awesome. And finally, for part C, find in terms of A and B the vector OM. Okay, so O to M is this line here, and we don't know that vector, so we're going to have to take a different path. Doesn't matter which path you choose. I could choose OA AM, or I could choose OB and then BM. I'll still get the same answer, but since we've already worked out AM, it's worth choosing this path here so we can use our answer from before. So we can say, what are we finding? We're finding OM. So we can say OM is OA plus AM. So it's worth also, just like the last question, so it starts at O and ends with M. So we've definitely got the path right. And what is OA? We know OA is 5A. And what is AM? Well, we've just worked out AM here. It's minus 5 over 2A plus 3 over 2B. So this is what we're working out. So I'll bring this down to the bottom and we're simplifying this. So we can say that that equals 5A plus minus 5 over 2A, which is just minus 5 over 2A, plus 3 over 2B is just plus 3 over 2B. Let's collect like terms and simplify. 5A minus 5 over 2A, well, 5 over 2 is 2.5. 5 minus 2.5 is 2.5, so it stays as 5 over 2A plus 3 over 2B. And that's my final answer. I'll just put that here. 5 over 2A plus 3 over 2B. And if you did the same working out going OBBM, you'll still get the same answer as that as well. But since we've already worked out AM, it made sense to use that other path. Okay, that's question 4. Moving on. We've got another triangle. So here it says OA is 2A, OB is 3B, P is the point on AB. So where is AB? This is AB here. And it says P is the point on AB. So P is a point here, such that this ratio exists. So I could just stick P here. And this ratio is saying that A to P, so this part here, that's 3 parts, and P to B is 2 parts. So this part here is 2 parts. So therefore, we can say all the parts all together. In total, we've got 5 parts of all of AB. So then we can express this ratio as a fraction. So we could say that A to P, so we could say A to P, since it's 3 parts out of the total of 5 parts, we can say it's 3/5 of all of AB. Likewise with PB, we could also say, since that's 2 parts out of the whole 5 parts of all of AB, we could say it's 2 out of 5 of AB. So if we worked out AB, then we could figure out what AP and PB is. Okay, so that's the relevance of whenever you're given a ratio and that point is lying on the same line. It says OP equals this, but they've not told us what K is, and we're finding the value of K. So what we're essentially finding is we're just finding the vector O to P, so this vector here, by taking a different path, and then hopefully we can factorize it and we'll end up finding K. Now, to find OP, I could go OA and then AP, or I could go, let me go back, or I could go OB, BP, I'll still get the same answer. So just choose any path you want, tell the examiner which path you're taking. So to find OP, I'm going to choose this path here, so OA, AP. So OA plus AP. We know what OA is. OA is just 2A. And AP, we've already evaluated that that's 3/5 of all of AB. Since the ratio is 3 parts out of the total of 5 parts of A to B. So we need to find A to B to be able to do this. So let's find AB. Which path can I take to get from A to find this vector here? I could go AO plus OB. Right here, I can go AO plus OB. So therefore, AB just equals AB equals A to O, which is minus 2A, since we're going the opposite direction of 2A, plus OB, which is just 3B. So therefore, we can find out what OP is, AP, sorry. So let's just work out AP separate here, and then we'll go back to OP. So AP is 3/5 of AB, which is this, what we've just found, minus 2A plus 3B. Expanding that out, I get minus 2 times 3, which is 6/5A, plus 3 times 3, which is 9/5B. Yep, so that's AP. So now let's substitute it into OP, everything. So OP, we've said is OA, which is 2A, plus, what is AP? AP is what we've just found here, minus 6/5A plus 9/5B. Let's simplify this. We get 2A plus minus 6/5A just gives you minus 6/5A plus 9/5B, which is just plus 9/5B. Let's simplify this. We've got 2 minus 6/5. Doing that in the calculator. 2 minus 6/5 gives me 4/5. 4/5A. And then we've got plus 9/5B. So we found OP, which is what they wanted us to find in the question, but they don't want us to just find OP, they want us to find the value of K. They've said to us that OP is K brackets 4A plus 9B. So we need to factorize something out to be able to get K out. So we can say OP, I'm going to write the bracket they've got, which is 4A plus 9B. Now I need 4 to times by something to give me 4/5A, which is here. and that would just be 1 over 5. Let's check that 1 over 5 works with 9b to give us 9 over 5b, and it does. 1/5 times 9b is just 9 over 5b, which is what we've got right here. So that's perfect. We've factorized it out perfectly. So therefore, it says find the value of k. Well, k is just 1/5. So worded a bit differently, this question. Rather than just saying find a vector, it's told you the answer to the vector in the question, where it's a factorized version, and they just wanted you to pull that number out, I guess. So that's the answer for question 5. So moving on to question 6. We've got A, B, C, D, E, F is a regular hexagon with center O. Just like that last question, it's a regular hexagon, meaning that this is parallel with this, which is parallel with this, so they're all the same vector. So DC is B, FA is also B as well. Likewise with this, OA being A, then EF would be A, CB would also be A as well. So that's the relevance of telling us it's a regular hexagon. It's then given us two vectors, OA is A and OB is B, which we can see on the diagram. It says M is the midpoint of BC. So remember, if M is a midpoint, so CB is the whole direction, then we can say MB is half of all of CB, sorry. And we can say CM is half of C to B, or vice versa, the other way around as well. So yeah, that's the relevance of M being the midpoint. It then says X is a point on AB extended. Okay, I'm just going to make this a bit smaller and just put it over here. So it says X is the point on AB extended. So here's AB. I'm going to extend it. And I'm going to say that X is over here. And it says such that A to B, B to X is 3 to 2. So it's saying that this is 3 parts. And it's saying that this is 2 parts. But we're not evaluating this the same way as the last question, this ratio, because in the last question, the ratio was just describing just one line, so all of AB. But here, the ratio is describing something extended, so the fractions are going to be a bit different here. What we can say is that BX, since we can find out what AB is just going to be minus A plus B. We can say that BX is 2 out of 3 parts. So it's 2 out of all of the 3 parts of AB. So we can say it's 2/3 of AB is what we can say about BX. So just to reiterate that, because a lot of students get confused with that, we know what AB is, we don't know what BX is. Since it's extended off, and we know it's 2 parts, where AB is 3 full parts, we're not adding the parts together because it's not on the same line. We're saying BX is 2 out of the 3 parts of AB. So that's a really important evaluation. So whenever you've got an extended line, it's always out of what it is for your middle. Okay, it's saying prove that E, M, and X are on the same straight line. So here's E, here's M, and there's X. We're proving that they're all on the same straight line. Now, to prove that they're all on the same straight line, there's 2 vectors I need to find. And the vector always has to start at the same point. So I'm going to find vector E to M. So vector E to M. And I'm also going to find not M to X, because M to X could be floating anywhere. To prove that they're on the same straight line, I have to go E to X. So I'm going to prove EM and E to X. And to prove they're on the same straight line, I'm going to prove that they are multiples of each other. So anytime you're doing a vector proof, to prove that certain points are on the same straight line, we're just proving that they are multiples of each other. And we always have the same starting point. So you can see we've got E in both cases. That's always the case. It has to be the same starting point. That's really important. Okay. Now let's just find EM and EX and see if we can manipulate them to make them look like multiples of each other. Okay, let's find EM. I always say to students as well, like, if you get confused with these questions, they tend to be 5 marks anyway, so you can still bag some marks by attempting to find vectors. So EM, how could I find EM? A few different paths I could get to EM. I could go ED plus DC and then CM, or I could go EF, FA, AB, and BM. You'll get the same answer. I'm going to take this path here, so EF, AB plus BM. Let's write that down. So I'm going to go E to F plus F to A plus A to B and then plus B to M. To double check you are right, your starting should be the same as here and your ending should be the same as here. So that path works perfectly. Let's work this out. So what is E to F? E to F, since it's parallel to O to A, that's just A. What is F to A? F to A is parallel to OB, so that's just B. A to B, we need to work this out. So we don't know what A to B is. Let's work it out here. So A to B, I could just go AO plus OB. So that's just minus A plus B. So minus A plus B. And then B to M, well, we know B to C. So B to C is parallel to A to O, and A to O is minus A. So B to C would be minus A. So therefore, B to M is half of B to C. So I'll just put that here. B to M is half of B to C. We know B to C is minus A, so therefore half times minus A is just minus a half A. So we get minus a half A for this one. So let's combine everything together and simplify. So we've got EM equals A plus B plus minus A, which is minus A plus B, and then plus minus half A, which is minus a half A. Let's collect like terms. A minus A, they cancel out, so I'm left with just minus a half A. And then we've got B plus B, which is 2B. So there you go, I have found EM. I'll just highlight that here. Do it like this actually. Okay, so we found EM. What other vector do we need to find? We need to find EX as well. So let's find EX. Let's see which path we can take. So E to X, so we're starting at E, going to X. Again, I could go this way, ED, DC, CB, and then BX, but since I've already found some vectors going this way, I'm just going to use that direction. So E to X, I'm going to do EAF, FA, AB, and BX. Okay, let's do that. So EX, I'm going to do E to F, F to A, and then it was A to B, and B to X. Let's check our starting and ending are exactly the same. E is the starting, X is the ending. Perfect. We know some of these values. So EF, well, I'll just start substituting it in. We know EF is A. We know FA is B. Just from this last one I'm looking up here. We know AB is minus A plus B. So plus minus A is minus A plus B. BX, we need to find this. So BX, I'm just going to do it down here. We've said it is 2/3. Did we write it somewhere? Yep, we've said it here. Let me move this to the side up here. We've already said BX is 2/3 of AB, so that's over here. So just to reiterate, it's 2/3 of AB because it's two parts out of the three parts that we know for AB. So 2/3 of AB, we know what AB is here, minus A plus B. Let's simplify that. 2/3 times minus A is minus 2/3 A plus 2/3 B. So we can put that down here. Minus 2/3 A plus 2/3 B. Minus 2/3 A plus 2/3 B for b to x. So let's simplify this for e to x. We have got a minus a, which cancels out, so we've got just minus 2/3 a. We've got b plus b, which is 2b, and then 2b plus 2/3 b. Calculate 2 plus 2 over 3 gives me 8/3 b. Okay, perfect. So we've got e to m and we've got e to x. And I'll just highlight them red here. We're proving that these two are multiples of each other. So what I always recommend is try and get a by itself first. Now I've noticed a is minus in both of them cases. So I'm going to put minus a inside the bracket. Okay. Let's look at EM first. What do I times by minus a to get minus a half a? Well, that's just a half. So a half times minus a gives me minus half a. Now a half times something gives me 2b. Well, a half times 4 gives me 2, and then we've got a b. So a half times 4b, that's 4/2. 4 divided by 2 is 2, so 2b. Okay, so we factorize that out. Hopefully, for the bottom one now, we get plus 4/b. So what do we times by minus a for the bottom one for ex to get minus 2/3 a? We just times by 2/3. Now, what do I times 2/3 by to get 8/3b? Well, we just times by 4b. Just to prove that to you, 2/3 times 4, that's times 4/1. 2 times 4 is 8. 3 times 1 is 3. So that's 8/3b. So that works perfectly. Now, what you should notice is they're both exactly the same. So now we just need to write our final concluding statement. You can't just leave the answer there. So you would say E, M, and X lie on the same straight line as EM, and E to X are multiples of minus A plus 4B, and both vectors start at E. Remember in the first part where we said that they have to have the same starting? So that's what we've done here. And that's for 5 marks. So I'll leave that there on screen. And we will do the final vector proof question. Okay, let's move over to the final vector proof question, question 7. It says here this diagram shows a parallelogram. Relevance of that is this side is parallel to this side, so BC would be 2A. And this bottom, which is 2B, will be the exact same as AC, so that'll also be 2B as well. So that's the relevance of telling us it's a parallelogram. They've told us two vectors, OA is 2A and OB is 2B, which we can see on the diagram. It says D is the point on OC such that OD to DC is 2 to 1. So here's D. And O to D, so this is 2 parts. O to D. So this is 2 parts. And D to C is just 1 part. So D to C, that's just 1 part. So we can evaluate the fraction since it's all on one line of OC. I can say, let's put it here. So if this is all O to C and OD is 2 parts, the total amount of parts is 3 parts. So 2 plus 1 part, 2 parts plus 1 part is 3 parts. So therefore, I can say that OD, so this part here, OD is 2 out of 3, so 2 parts out of 3 parts of all of OC. Likewise, with D to C, I could say that's 1 part out of the total 3 parts of all of OC. So just to reiterate, DC is 1 out of 3 parts of all of OC. Okay, so we've evaluated that ratio. It says E is a midpoint of BC, meaning BC, no, B to E, sorry, that would be half of all of BC. And E to C, well, that would also be a half of all of BC. So that's the relevance of telling us it's a midpoint. Okay, it says show that AD and E are on the same straight line. Where's ADE? So we've got A, we've got D, and we've got E. So show that them 3 are on the same straight line. Like last time, we are showing we're going to find vectors A to D and A to E. Remember, same starting point, they both start A. So A to D and A to E. And we're going to show that they are multiples of each other. It's worth writing this in the exam because you're telling the examiner you understand what you're doing. Let's find A to D. So we're just going to find each vector now, just like last time, and show that they are multiples of each other. So A to D, which way could I go? I could go this way. So let's do a different color. So A to D, I could go AC and then CD, or I could go AO and OD. You'll get the same answer. So I'm just going to go AO, OD. Tell the examiner that I'm going to go AO plus OD. So A to O is 2A, and O to D, well, we've said O to D is 2/3 of OC, so we just need to find OC. What is OC? To get OC, I could go OA plus AC. And what is AC? AC is 2B because it's parallel to OB. So this up here is 2B. So therefore, O to C is 2A this way plus 2B the other way. So therefore, OD is 2/3 of OC, which we've said here, because it's 2 out of the 3 parts. So of OC, which is 2A plus 2B. Let's simplify this. We've got 2A plus 2/3 times 2A is 4/3A plus 2/3 times 2B, which is 4/3B. Let's collect like terms. So we've got AD equals 2A plus 4/3AO. Oh, sorry, this should not be AO. That doesn't make sense. AO and then AO and then OD. Oh, okay. AO should have been minus 2A, sorry, because I'm going in the opposite direction. So I forgot that minus sign there. This should be minus 2A because AO, I'm going in the opposite direction. Should have spotted that. That's minus 2A. Minus 2A plus 4/3A. Let me do that in the calculator. Minus 2 plus 4/3 is minus 2/3 A. And then we've got plus 4/3B. Okay, perfect. So we found AD. Now let's find AE. So AE, which path could I take for A to E? I could go AC and then CE. So let's do that. I'm going A to C plus C to E. Yep, the starting and ending is the same as the starting and ending. So AC is just 2B because it's parallel to OB. So that's 2B. And then C to E, well, if I just rub these out because they're irrelevant because they're going in the other direction. Okay. That blue again. Okay, so I need C to E. So C to E is half of C to B, and C to B is the opposite of that, which is minus 2A. Since going up is 2A, so the opposite is minus 2A. So C to E, sorry, would be half of that, which is just half of minus 2A is just minus A. That's just minus A. Plus minus A just gives you minus A. So we found A, E. What I would do is I'd put the A first, just so it's easier to compare the multiples. So I'll write minus A plus 2B. There you go, we've got AE now. So now we just need to do the step of proving that they are multiples of each other. So since we've got minus A on the bottom already anyway, let's try and get, so I'm going to leave minus A plus 2B here. I can't really factorize that, so I'm going to leave it as is. This one here, I'm going to try and get minus A plus 2B. What are times by minus A to get minus 2/3 A? That's just 2/3. 2/3 times something gives me 4 over 3B, which is just plus 2B. Because 2 times 2 over 3, that's 2 over 1. 2 times 2 is 4. 1 times 3 is 3, so 4 over 3B. And just like before, as expected as well, we've got the same multiple. So let's write our final concluding statement. I'll just do it in a different color. We can say that A, D, and E lie on the same straight line as AD and A to E are multiples of minus A plus 2B and start at A. Because both vectors, they do start A, right? We've got AD, we've got AE. We didn't find D to E, so we started at the same. And that's the answer for 4 marks. So that's the end of this session. That's a range of different things on vectors for GCSE. So I hope you found that useful. If you've got any questions, do ask as well. And do check out our other videos as well that we've got on our YouTube channel. And you can have a go, look at our website as well on any sessions that we're holding as well for any current GCSE students or even A-level maths as well. But thank you for joining, and I'll see you on another one.